Okay, guys, welcome back to Unit 4B. Going to page 29, Section 4.7 is we're going to learn how to solve equations again. As you can see, we have quadratic equations again. We're going to learn a new method for solving them called the quadratic formula. So the quadratic formula is best used if you're not able to factor, or if you can't easily notice that you have the square root method. So here's the formula. You should try to commit this to memory. So it's negative b, then a plus minus to represent two answers, then a big square root, and within the square root, you do b squared minus 4 times a times c, and then all in a big fraction where you finally divide by 2a. I know this seems a little confusing now. Just be patient until we hit the problems. So here's the steps. You want to write these down now. I will go over these. I will talk you through them as we go through the problems. Going down to example 1. The first step is always set the equation equal to 0, which it is. So after that, we look at what a, b, and c are. The a is always the term in front of the x squared, so the a here would be an invisible 1. The b is 3, so a is 1. B is always with the x term, so it's 3. And the c is always the constant term, so it's negative 2. So we're going to take these three numbers and plug it into the formula. So you're replacing a, b, c in the formula. You're no longer going to have an a, b, or c. You're going to have a bunch of numbers in there. Numbers and mathematical operations. So again, this is solving for x. We are finding out the two x values that make the equation true. So negative b, so that would be negative 3, followed by a plus minus square root of b squared, in the radical b squared, so that would be 3 squared. Please make sure you're using parentheses when you're doing the b squared. And then minus 4 times a times c. And then we have a huge fraction. And then on the bottom, 2 times a, so that's 2 times 1. Okay, so that's substituting in. Now we have to simplify this using the order of operations. And feel free to use a calculator at any time here. So what I do next is I multiply 3 times. I'll highlight the things I multiply. I multiply this, then I multiply this, then I multiply this. I can do that in the same step to save me some space. So 3 squared is going to be 9. That b squared, whatever you remember when you square something, it's always going to be positive. So the b squared term will always be positive. And then negative 4 times 1 times negative 2. Multiply those three numbers together to get 8, so we put plus 8. Then in the denominator of the fraction, 2 times 1 is our third way of multiplying, so that's obviously 2. Okay, after that, what we want to do is there will be two numbers remaining in the radical. We want to either add or subtract those, whatever it shows. In this case, adding. So 9 plus 8 will get me 17. And then after that, you would try to see if you can simplify the square root of 17. However, there is no perfect square. Remember, we learned our perfect squares the other day. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. But none of those numbers can multiply into 17 evenly without a decimal. So since this radical cannot be simplified, we would actually stop here. So this thing is my answer. Okay, let's move on to the next problem, example 2. The first thing I notice is it is not set equal to 0. So I need to subtract 1 to move it to the left. So the A is 3, the B is an invisible -1, and the C is also -1. Now I'm going to go to my quadratic formula. In the formula it says -b, but b is a negative. So double negatives change to a plus, or a positive, then a plus minus. Now our giant radical, and of course giant fraction. And in the radical, we're going to have to do b squared minus 4 times a times c. In the denominator, 2 times a. Okay, so we plugged into the formula. Now we're ready to simplify it. So remember, we're going to do our multiplying 3 times. Once here, second here, and third here. Oh, on the bottom, I screwed up a little bit. I put 2 times a. I forgot to substitute in the number for a. That should read 2 times 3. All right, so let's multiply our 3 times. So -1 squared should be 1. Remember what I said, when you have that b squared, when you square a number, it's going to be positive. So 1. And then -4 times 3 times -1, that'll be positive 12, so plus 12. Denominator, 2 times 3, we'll get 6. Next, we would add or subtract in the radical. So that would be 1 plus 12 would be 13. Bring down your square root and your fraction. Then after that, you would look to your radical. Can you simplify the square root of 13? No, you cannot. There is no perfect square that multiplies into that. So you actually stop this early, just like the last one. And we have our answer. Or answers, I should say. It's technically 2 answers. The answers are 1 plus the square root of 13 over 6, and 1 minus the square root of 13 over 6. All right, bear with me, I'm just looking ahead. Okay, let's try another one. Example 3. I notice right away this is not set equal to 0 like step 1 says. So I had to subtract 4. So the a in front of x squared is an invisible 1, b is -6, and c is -4. I'm going to go to my formula now and substitute in the 3 numbers for the 3 letters. The formula starts with -b, so that would be b is a negative, so double negatives would make a positive 6, plus minus. Let me draw in my giant square root and my giant fraction. Then in the radical, b squared minus 4 times a times c. The denominator, 2 times a. So they're substituted in. Now let's work on simplifying. Let's do our 3 multiplications. 1, 2, and 3. So negative 6 squared is 36. Again, b squared, always positive. Negative 4 times 1 times negative 4 would be 16. Again, you could use the calculator for that. So put plus 16. Denominator, 2 times 1 gets the 2. After that, simplify it, add or subtract in your radical. That'll be, let me just bring this down. So we're adding 36 plus 16 to get 52. Now we must break down our radical. Now I do know a perfect square to simplify this. The square root of 52 can be broken down as the square root of 4, or 4 is a perfect square that multiplies into 52, and it multiplies in 13 times. Pretty much what the operation you do in your head is 52 divided by 4 is 13. So then this radical we finally have our first radical where we are going to simplify it. So it'll be plus minus 2 times the square root of 13. Now, after simplifying a radical, you should always be on the lookout to see if you can reduce this fraction more. Remember, it is a fraction after all. So I'll repeat that. When you pull a number out of the radical, you need to try to check to see if you can simplify the fraction. So here's what I would suggest. I would suggest splitting this up into two fractions, such as 6 over 2, and then the plus minus 2 root 13 over 2. And then going from there, you can reduce each individual fraction. 6 divided by 2 is 3, followed by the plus minus. And then here the 2's cancel, so what's left is the square root of 13. So here are your two answers. 3 plus square root of 13 and 3 minus the square root of 13. Okay, I'll skip you do 1. I'm worried about, that's just repetitive if we were in class. Example 4. So here it is set equal to 0. A is invisible 1. B is negative 10. C is 9. So let's substitute into the formula. So negative b would be double negatives again to be a 10 positive. Plus minus big square root with a big fraction. In the square root would be b squared minus 4 times a times c. In the denominator, 2 times a. So now we're going to work on our multiplying 3 times. 1, 2, and 3. So b squared will be, negative 10 squared will be 100. And then negative 4 times 1 times 9 will be negative 36. So we'll write minus 36. Denominator, 2 times 1 is 2. Now let's subtract. (100 minus 36) will be 64. Okay, remember after that, we want to try to simplify the radical. Square root of 64. You should notice that's a perfect square. Square root of 64 is simply 8. So we have our first problem where the radical goes away. No more radical. So what we're going to do is this. We are going to get two integer answers, meaning two, you could call them whole numbers if you want. So we're going to split this up to get our two answers. For our first answer, we're going to do 10 plus 8 divided by 2. So that'll be 18 divided by 2 is 9. And for the second one, you do 10 minus 8 divided by 2. So that'll be 2 divided by 2 is 1. So you have two distinct answers here. 9 and 1. Okay, let's try another one. Please make sure you're rewinding if you need to. If you need refreshers. First thing I notice is it's not equal to 0. So we're going to subtract 1. I just got to check something here. Okay. For a second I thought it was a repeat of earlier. So A is 2. B is negative 1, and C is negative 1. So we're going to substitute into the formula now. Negative B, that would be double negative, so positive 1 plus minus square root of B squared minus 4 times A times C. I'm going to start going a little faster now because I'm looking at my time, and I'm already at the 16-minute mark. On the bottom, 2 times A, which is 2. So now I'm going to multiply my 3 times. 1, 2, and 3. Don't lose your radical. Negative 1 squared is 1. Minus 4 times 2 times negative 1 would be a plus 8. On the bottom, 2 times 2, 4. Remember, you add or subtract in your radical next, so I'm going to be adding that to get the square root of 9. Remember, after that, you want to try to get your square root. What is the square root of 9? Easy, it's 3. There's no more radical, so that means we're going to go get our two distinct answers now. 1 plus 3 divided by 4 will be 1, and 1 minus 3 divided by 4 will be negative 1/2. So we have our two answers, two real numbers, and you're good to go to the next one. Okay, don't worry about you do too. Let's go to example 6. Definitely looks a little odd here. Well, first thing to worry about is we need it set equal to 0. All right, so we subtracted 5 to set it equal to 0, but we only have two terms. So what's A, what's B, what's C? Well, remember the A is always in front of the x squared term. So the 6 is the A. The B is always the x term. That's not showing here. So the B is actually 0. The C is always the constant, the one that does not have the variable. So the C here is negative 5. Okay, now let's plug into our formula. Negative B plus minus square root of B squared minus 4 times A times C divided by 2 times A. Let's multiply our 3 times. 1, 2, and 3. Actually, since one more thing, since you have a 0 here in front, you could just get rid of it. It's always nice when B is 0. Actually makes things easier. So plus minus the square root of 0. And then negative 4 times 6 times negative 5 is positive 120. On the bottom, 2 times 6, 12. Now we're going to add in our radical to get the square root of 120. And we got to try to simplify this radical. Is there a perfect square that multiplies into 120 evenly without a decimal? Yes, there is, and it's actually the number 4. So that becomes the square root of 4 times the square root of 30. So to keep simplifying, we can say plus minus. The square root of 4 is 2. Bring down the square root of 30. And then over 12. And remember what I said earlier. When you pull a number out of a radical, you must try to reduce the fraction, which you can here. If you notice this, 2 divided by 12, or 2/12, can be reduced to 1/6. So 1/6, carry over the square root of 30. And then, technically you wouldn't leave a 1 in front of a radical, you just make it invisible. So this would be positive and negative square root of 30 divided by 6. Believe it or not, you have to stop here. You cannot divide the square root of 30 divided by 6 to get 5 or root 5. You do not do that. You cannot divide a radical divided by a actual real number, okay? Radicals can divide with radicals, real numbers divide with real numbers. Technically, they're called rational numbers, but not going to worry too much. Okay, guys, good timing. That was about 22 minutes, and I finished the problems that I needed to. So you guys should be good to go to have at your homework. Watch more YouTube videos if you want to get more practice on this.